All right, guys, we are going to be working through some of the examples on the first and second sections of your semester exam review. So first section is on vectors. So first vector here is -5, 12. It says to find the magnitude and the direction. So -5, 12, we were to draw that. Okay, remember this is your horizontal and your vertical. So you'd go to the left, 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be your vector, just like that. Okay, magnitude is the length. You will get a formula chart for the semester exam, but remember that's going to be a squared plus b squared, then take the square root. So it would be 5 squared plus 12 squared, and then square root that. Notice that I'm leaving out the negative because if I put the negative or don't put it, do you see how it actually really doesn't matter? Okay, just make sure if you do put the negative that you include it inside these parentheses. Okay, but easier, just kind of leave it off. So that gives me root 169. And then I just want to check and see if that comes out to a whole number or if I'm going to have to round it. Square root of 169 comes out to 13. Right next to it, we're asked to find direction. Remember that for direction, you start out with tan theta equals y over x. But then remember that you're going to use inverse tan on both sides to solve. So for this one, my y is a 12. My x is a 5. Remember, we don't really care about the negatives here. So I'm going to inverse tan on both sides. And then put that in your calculator. Make sure your calculator is in degree mode. So let's see what it is here. Second tan, 12 over 5 comes out to 67.3, which means that your theta is 67.3 inside the triangle. Okay, but remember, that's not how direction is measured. Direction has to start from here and then go all the way around. So if I'm in quadrant 1, let's do your little chart here. It's theta, keep it the same. 180 minus theta, 180 plus theta, and 360 minus theta. So I see here that I'm in quadrant 2. That means I'm doing 180 minus. So 180 minus 67, that's going to come out to 113. Okay, but remember that first answer that you get, that's called the reference angle. And then you turn it into direction by checking your chart. Okay. Okay, we'll do one more of these. We'll come down and do number 4, please. Okay, so you want to find 2u minus 3v. So I'm going to do 2u minus 3v. And then I'm going to take my coordinates for u and v, and I'm going to plug those in. My u coordinate is 7i plus j. My v coordinate is 8i minus 3j. Okay, and then if I work this question out the way that it's written, I'm going to get it wrong. Because remember that the 2 and the coefficient of 3, those need to be applied to both components of the vector. So to show that, you're going to use parentheses. So 2 times 7i is going to give me 14i. 2 times j is going to be 2j. Then we're going to move to our 3. Keep in mind that negative is going to go with the 3. So negative 3 times 8 is negative 24i. Negative 3 times negative 3 is a plus 9j. Then from there, remember your horizontal and vertical components can only go with the same type. So my 14i and my minus 24i are going to combine. 14 minus 24 is negative 10i. And then 2 plus 9 is 11j. Okay, also keep in mind, since your exam is a multiple choice, that would be the same as -10, 11. Okay, so remember that these are your standard vectors, okay, versus this is component form. Okay, this is standard unit vectors. And this would be component form. All right, go ahead and turn the page. We'll do 1 or 2 examples from the polar section, and then that will be the end of our video. So taking a look at this top section here, you're naming your coordinates 2 ways. Remember, for a polar, it's r, theta. Your theta can be measured in either degrees or radians. You'll just look at what's on your circle. So in this case, I see that this is radians. Okay, and then I'm noticing now that I'm looking at this, some of these are wrong. So this should be 3 pi halves. This top one is pi halves. And if you look on your circle, you should have these all correct. This is 3 pi fourth, 5 pi 6 pi. Okay, I think, oh, and then this should be 11 pi 6 and 7 pi fourth. Okay, so just be careful, maybe check your circle when you're working out this top section. Okay, so it says name each of the points 2 ways. So let's do P first. So first thing I'm looking for is my point is here. So I'm going to count out how many rings away from the center that is. So it's 1, 2, 3. So my radius is 3. And then the ray that I'm on is pi over 6. So then it says to list it a second way. So the second way that I'm going to list it is using -3 as my radius. Now remember that if my radius is a -3, that means that I need to be counting in the opposite direction of the listed angle. So if I want to be counting 3 this way, 1, 2, 3, and have it be negative, then I would need to list 7 pi 6 as my angle. Okay, and then remember, you could also use a negative angle instead of a negative radius. Either way would be fine there. 6 and 7, you're asked to plot the points. So we'll just do the first one here. I want 3, 5 pi 6. So 5 pi 6 is here. And then we want to count out to the third ring. So if that's 5 pi 6, I'd count out 1, 2, 3. That would be point X. And then you'll do the same thing for point Y. Okay. All right, last 2 parts for polars that we learned how to convert these. So if you start off with an r, theta, and you're wanting to turn it into an x, y, the formulas that you're going to use are x equals r cosine theta and y equals r sine theta. So for this question, I see that my r is a 3. My theta is 5 pi over 6. My y is going to be 3 times sine of 5 pi over 6. Okay, then from there, you're going to go to your unit circle. Okay, so I have a big one here. You're going to find 5 pi over 6, and then remember that cosine is the x value. So if I'm at 5 pi over 6 on my circle, that would be here. My x value is -√3 over 2. And my y is 5 pi 6. My y is a half. So it'd be 3 times a half. Okay. Then from there, if you can multiply or divide numbers that are on the outside, you should do it. Okay, but in this case, my 3 is going to turn negative. And then I'm going to try to divide it by 2. Well, then that's just going to stay as a fraction. So my x is going to be -3 √3 over 2. Same thing for my y. If I could cut 3.5, I would do it. But if I can't, I'm just gonna leave it as 3/2. So when you turn that into an XY, it would be -3√3/2, comma 3/2. And then you should understand that what we talked about is if you graph this one and you graph this one, they'll be in the same position. Okay, the word for that is coterminal. Okay, that will be on your exam, but that means you end up in the same final position. Okay, on the circle, on the polar graph. Okay, so we did one of your top examples. Now we're gonna do one of your bottom examples, and we will go ahead and do letter B for this one. So you're starting with an XY this time, and you're wanting to turn it into an R comma theta. So to find the R, you're gonna do X squared plus Y squared, then take the square root. And then for your theta, you're gonna do tan theta equals Y over X. Okay, remember that for both of these, you really don't have to put the negatives, although you can if you want to, just make sure you put it in parentheses. So for my X, it's gonna be 5 squared plus 7 squared. I'm gonna go ahead and put that into my calculator here. 5 squared plus 7 squared comes out to be 74. And then if 74 is R squared, then square root both sides and your R is root 74. Now, when we did this on Delta Math, we left it like that, but because it says to round it to the nearest hundredth, I'm gonna actually take the square root of 74. So it's gonna be 8.60. Okay. Then for the second part of this, we're doing tan theta equals Y over X. So my Y is a 7, my X is a 5. Remember, nobody cares about the negative. And then you're gonna inverse tan on both sides. Remember that the tan inverse is what crosses out regular tan so that you have theta equals in your calculator. So second tan 7/5 comes out to 54 degrees. Okay, remember that's your reference angle. To turn that into direction, you need to check your chart. So if I were to graph -5, -7, let's do like a little baby graph here. I would go to the left 5, so 1, 2, 3, 4, 5, and then down 7, 1, 2, 3, 4, 5, 6, 7. So that puts me in quadrant 3. And the formula for that is 180 plus 54. 180 plus 54 comes out to be 234. So if you were to rewrite -5, -7 in a polar coordinate, it would be 8.6 for your radius. You can put the 0 if you want, and then 234 degrees for your theta. Okay. All right, that should get you through the first 2 sections. Check the next video for section 3. Have a great day.